Welcome back, everybody. Part 7. We're going to take this solution right here, siphon this down into my waste bucket. All the precious metals have been removed from this solution now. So we'll siphon the waste solution into my waste treatment bucket. Transfer the silver into my collection bucket that I have here, that I've set aside to collect all my silver. It's about 1/5 full of silver there. I'm just going to transfer the powdered silver out of this container now into here so we can get our beaker back in service. Silver that we've recovered from this process so far. There's a little bit in here when we started, but not much. These pieces of copper will be used to smooth out silver in a future video. But you can see the level of silver. This thing's about 1/3 full of silver powder. I've got a melt dish here, and what I'm going to do with this is back here. This is the solids that we recovered and filtered out of our solution. I'm going to put in this melt dish down here. And then what we'll do, I've disabled the temperature device on it, so that it heats up and keeps heating up. And we're going to burn all the combustible material off of this, off these solids here in this melt dish in my homemade oven. This is looking inside the oven where the controls are. And here's the controls on the outside. And what I've got here is a little thermostatically controlled switch. There's a prong right here, and then there's another prong right over here. And it had these two wires connected to this thermostatically controlled switch here. Probably had a bimetallic element in it that would open up when the temperature got to a predetermined point. What I did is I just took the lugs off, the wires off of the lugs, and then I fashioned a piece of copper so that I could slide these two together. And so now we've got a direct circuit, and eliminated the thermostat here so that the oven will heat up to 800 degrees for us and become an effective incineration oven. This homemade oven will get up over 600 degrees, maybe even close to 700 degrees. And that should be enough to burn all the combustible material off of our paper, off of our solids, and do a nice incineration here. So we'll just let this stay in here for a while until everything burns away. Material's been roasting in my homemade oven here for about a half an hour. Now we're going to open this up and see what kind of temperature we got. I've got 394 Celsius, 742 Fahrenheit. So we're going to take this out now, and I'm going to turn the oven off. Worked pretty good. And now we'll just let this cool off up here. That should have burnt away everything that needed to be burnt away. We'll let this cool off and go from here. Got a small propane torch here. What I'm going to do is just make sure we got everything nice and burnt away. That's going to burn. Looks like it already is pretty much. Here I'm taking a small steel spatula to break up the solids and continue to incinerate, just to make sure that I've got everything in there nice and burnt up before we go to the acids in the next step. Here's our incinerated material. It's not very much. What I'm going to do is put it in this beaker here, and I'm going to put it up on the stir plate there. I'm going to add a stir bar. Up on the plate over here. Add some hydrochloric acid now. About 100 milliliters, I guess. I'm going to start the stir bar. This up now. Alright, this material here is the solids that we recovered from the anode filters, and we removed anything that would dissolve in nitric acid from these solids. That should include silver and palladium, and there's some base metals that might have been in there. We've got that all removed with the nitric acid. Now these are just the solids left over. We'll start applying some heat, and I'm going to add some nitric acid to this. We're going to try to put whatever will go in solution. I'm going to try to put it in solution in this beaker now. I'm adding concentrated nitric acid. Form some aqua regia in there. waiting for this reaction, what we'll do is turn our attention over here to the solids that we have in these beakers back here. This is going to be our palladium that we precipitated with dimethylgloxine. Let me get some scissors here. Let me get the material out of here on these beakers, and I'm going to cut away part of the part of the paper, so we don't have a bunch of paper that's got these stains in it here. I'm just going to cut this away. Doing this in my fume hood to draw these the dust from this. This is bone dry. It's going to be throwing off some dust, and we don't want to be breathing this stuff. Highly toxic. Alright, I'm going to let this fall down into our reaction beaker here. And this piece I will add to my paper storage and save it for later. Reach back here into this other beaker and get this other filter out of here that's full of palladium salt. And I'm going to do the same thing. I'm going to cut away the excess paper here. Get rid of this excess paper. Looks like it's got a little bit of silver on it still. We don't want that down in our reaction vessel. Save this paper in my paper storage here. Here's our material that we've got in our beaker here, and what we're going to do is stick this up on the burner in the back here. And now, if I can rearrange the camera right here, I'm going to add some hydrochloric acid to this material, and we're going to form aqua regia in here and dissolve this. It's filled up to about the 300 milliliter level. Now we're going to add some heat to this back in the back here, and I'm going to add some concentrated nitric acid to form aqua regia so we can dissolve this yellow precipitate. And if any of you have seen any of my previous videos, I did this in a previous video, and I added the nitric acid too fast, and I got a runaway reaction, and it spewed the hot solution and acid all over the place, made a big mess. So we're going to do this real slow this time. Just add small quantities of nitric acid in there, because this will, what it'll do, it'll wait, and you get a delayed runaway reaction. So we got to add that nitric slowly, and then just let this set. Been on the heat back here now about a half hour. I'm going to add a little bit more nitric acid. I can see some solids down in the bottom of the beaker there. It's about 1.5 milliliters. I that in. Now we'll see what happens here. I don't want to create a delayed runaway reaction. Give it a stir here. Both reactions have been going for an hour. I'm going to add a little bit more nitric to both of them. Just a little. Don't want it to boil over. And if you look back in this one here, you'll see we've still got a bunch of little yellow flakes in there of the palladium salt that we precipitated out with DMG. I'm just going to keep adding nitric in small quantities until we get all that to go into solution. We're going to add some more nitric acid to our DMG precipitate back here. See if I can get the rest of those chunks to go into solution. Make sure that the reaction hasn't stalled. I'm going to add about 50 milliliters of hydrochloric acid here. 50 milliliters of hydrochloric acid going in right now. All right, I'm going to add a little bit of hydrochloric acid to this reaction as well. Just to make sure it doesn't stall out on me. Fresh acid's going in. I'm going to add just a touch more nitric to each of these. Solution on here, stirring with heat off the regia for about 2.5 hours now. This one's going to contain some gold and platinum group metals. I'm going to turn the stir bar off, turn the heat off now. Back here in the back, we've got our material that was precipitated out of our solutions with dimethylbloxine, DMG, and what we should have in here now is palladium and platinum in solution. I'm going to turn the heat off on this one. We'll let that one cool down as well. Got a piece of filter paper here. I'm going to stick it down into our beaker here. Get a little bit of the solution on there. I test it with some stannous here. As you can see, I got a dark brown stain, which tells me I have gold in solution. Now let's filter our solution here. See if we can get the gold precipitated out of here. We got quite a bit of solid material left in here. quite sure what that is. Might be some platinum group metals that didn't dissolve in that aqua regia. We'll catch this in the filter and then save the filter for later. Solution back through the same filter a second time here. I'm going to try to get it cleared up real good, and then we'll precipitate this out and get a yield on the amount of gold that came out of that. Alright, I've got this poured back through the same funnel for a second time. Once we get it all pulled through the funnel or the filter, we'll precipitate out the gold and get a yield on the gold. Here we go. We're going to take and precipitate the gold now out of this solution. Here you can see contents there. That might be rhodium, or it might just be dirt. I don't know if any of you professional refiners recognize anything you see here. Make sure and leave a comment down in the comments section for me, please. And we're going to transfer our solution into this beaker now. It's got some precipitate that came out of the solution, junk that's in there with the gold solution. I'm not worried about that because I'm not going for high purity here. I'm just trying to extract the gold so we can get a yield. I'm going to pull some sodium metabisulfite up here, and we're going to add some SMB to take the gold out of the solution. Here we go. Settle. Now what we'll do is bring this solution down. What we need to do here is filter all the solids out of here, and then we're going to precipitate the metal out with pieces of pure zinc. Alright, I've got a filter set up here, and we're going to pour the solution now to this filter paper. Filter out all the solids and gather the dissolved platinum and palladium in the flask. Like coffee. Just about all this material pulled down through the filter here. Pull the last little bit in, and then we're going to rinse the beaker out with some hydrochloric acid. That's just filter paper. that solution pulled down through this filter. If you look in here, all that's in here is some filter paper from the reaction that we did earlier. I'm going to transfer our solution here into this beaker. Then we'll add some pieces of zinc to this. This will react fairly vigorously here. Give this a quick rinse. Now what we'll do is add some zinc to this, and this will precipitate out the pure platinum and palladium that's in the solution. That's all that should be in here, is platinum and palladium. In accordance with the reactivity series of metals here, the zinc immediately begins to go into solution as the platinum group metals come out of solution on that zinc. Almost there. Need to add a couple more pieces of zinc here, and the solution will turn from a burgundy color to a greenish color when this reaction is done, and you'll be able to see the platinum and palladium precipitate out as a black powder. I've got most of the metals cemented out of that solution now. There's one little piece of zinc left. And what I'm going to do now is get this solution, this clear solution, off of the metal by pouring it off into this beaker here. It's just going to be a waste solution. We'll end up probably adding this to the stock pot. A little bit of the precipitated metal will come over with it. That's okay. What we're interested in is right down here in the bottom, our platinum group metals. In a powdered form. I'm going to get some water on there now to stop the reaction. I'm just going to add some distilled water because this is going to want to try to go back in solution here. It's just the nature of the platinum group metals. I'm going to rinse this off real good. This out into a temporary container, and we'll use this. We'll put this in the stock pot. It's going to be a waste solution that I'm pouring off here. Bang! There's our platinum group metals. Black powder. Got a beaker here. Get the weight of the empty beaker. Looks like it's 178.7. 178.7. I'm going to write that right on the side of the beaker. transfer the solution, or the precipitate rather, out of our big beaker to our small one. And then we're going to do multiple rinses on this to get all the zinc rinsed off of our mixed black PGM powders here. Got a little test strip here. I'm going to put it down in our solution, and you'll see that we've got a pH of about 1. So I got to keep rinsing this until I get the pH fairly close to neutral. What I'm trying to do is rinse all the acid out of here. Once I get all the acid rinsed out, it's fairly safe to conclude that the zinc will be rinsed out as well. Any dissolved zinc that's left in there. You'll notice that the precipitate settles quickly, and it's making some nice big curds there that stay together and stick together well. Settles quickly. It doesn't make a bunch of colloidal stuff that gets up in the rinse water there. Let's take another quick reading here with a little pH test strip that I've got. See if we got most of that acid rinsed out of there. About 4 on the pH there. I'll do a few more rinses until we get it pretty close to 7. In here and do another test here, and we're looking about the 5 range. That should be good enough for what we're wanting to do here. What I'm going to do now is put it up on the heat. Turn some heat on back here. I'm going to slowly dry this black powder so that all the moisture is gone from it. And then what we'll do is we'll weigh the beaker again with the material dried off, subtract the weight of the dried beaker, 78.7, and then we'll be able to tell how much metal we've got in there. I don't want my stuff to spatter all over the place. So what we're going to do here is fill this thing with water, and then we'll be heating the water and prevent the water from boiling in our beaker, and then we won't have to worry about it spattering as the material, the black powder in the beaker, dries off. Some glass rods in here. give us the right temperature that we need in there. Shouldn't get above 212 degrees because it's got to transfer the heat from the water into my drying vessel here. I think our powder's almost dry. While I'm waiting for it to dry the rest of the way, I'm going to take and filter our gold out of this waste solution. That we recovered. I'm going to transfer it now into this melt dish. So what we'll do is take it over on the melt table and melt this up into a little bead so that we can get a yield on the amount of gold that we got out of these silver cell filters. Material is completely dry now. We'll pull it down off the heat and we'll let the rest of the moisture evaporate off of here. Then we'll get a weight on it and see what kind of weight we got. Here's our little button of pure gold that we just melted from our silver cell filters. That one's 1.2. Here's the other button that we got from the one of the previous videos in the series. So we got about a little over 2 grams of gold, about 98% pure gold out of there. And then we've got our platinum group metals here. This is completely bone dry. I dried all the moisture out of here. And so we took a measurement on the beaker before we started, 178.7. And now we got 183.0. So that's about what? A little over 4 grams of platinum group metals here. This is it. Part 7 is done. I've got the platinum group metals divided out. This will be probably some platinum and palladium that we extracted out of our solution with DMG. Then I was able to get another little BB of gold here. And so we got a total now of 2 grams of gold. This one's pretty rough looking. It's got some silver in it and some other stuff, but this one came out pretty good. It looks pretty nice. So we got a couple grams of gold, about 4 grams of platinum group metals, and in the next section what I'll do is set up and refine that metal and see if we can get some pure platinum and pure palladium. And that'll do it for this video, man. Thanks for watching.